Hello, this is Professor Elliott, and in this simulation we're going to take a look at how the changing the load resistance varies the Zener voltage. So this is essentially the circuit from lab experiment 2, and here we have a power source E of 9 volts. And we're just calling that our input voltage Vn, which we're going to show on the meter here. This meter here is going to measure the voltage Vr, which is simply across R1. This resistor here is necessary to provide current limiting for the Zener diode. And the load resistance RL, which we're going to start off at 2K and then lower the resistance. And then monitor the load voltage VRL. You'll note that VRL is of course the Zener voltage because RL and the Zener diode are in parallel, so the voltages are the same. So right now we can see that the nominal Zener voltage is 6.8 volts. Our actual measured voltage is 6.77, and our E is 9. So our voltage here always has to be larger than the Zener voltage if we want the Zener to remain in what we call regulation. And the difference in the voltage here and here shows up across that series resistor. Okay, so take note of those values. Okay, so all right, so I got to just move this. Oh, there we go, went away. Okay, so I'm going to turn on the simulation. Okay, just refresh and update the numbers. Okay, so now I have to stop it. I'm going to change this to 1K. Sorry, it doesn't allow me to change the components live and have it update. You got to keep stopping the simulation. But anyway, okay, so you can see that basically no change. Okay, because the current through the load is still quite small and it's not burdening the Zener at all. So we're just going to keep lowering that down. Go to 500. Switch it back on. Okay, you can see there's a very slight drop in voltage at the load, but not that much. Okay, so let's take this down. Let's take this down quite a bit. Okay, now you can see that the voltage at the load resistance has dropped. And the reason is because now the load resistance is sufficiently low that it's going to demand enough current right here. Okay, and this current is given by this formula, right? This current here, that is, you can think of it as it's siphoning off or reducing the current available for the Zener diode. Okay, and if hopefully you've read some of my other videos and materials already because it's in there, but the minimum current that you must maintain through the Zener in order for the Zener to exhibit Zener action or behavior is called the Zener knee current. And once you start to fall below that current, then the Zener is not really doing its thing anymore. Okay, and that's why we're seeing the voltage now here is dropping, and of course the load resistance voltage has increased as a result. Okay, so let's take this down to 100. Okay, hit. Okay, voltage is down now even more, and of course this voltage here increases, and of course because this is just simply a series circuit, basically, I mean these two are in parallel, but okay, this voltage here plus this voltage here must always equal 9. So as we decrease that resistance, this current increases, this voltage goes down, this voltage goes up. Okay, so let's take this down now to our final step at 50 ohms. Okay, and then we're going to then restart the simulation. Okay, and the voltage is down even lower. Okay, so once the load voltage starts dropping getting below the significantly below the Zener voltage, then it's no longer to be considered to be in regulation anymore. Okay, so I'm just going to stop this. I'm going to return this back to its original value of 1 k ohm. Okay. Okay, so now our voltages are all back to normal. And now I'm going to change this here. And I'm going to intentionally lower it down to 6 volts. I want to intentionally get us below the Zener voltage. Okay, so we turn that on. Okay, so what you see now is that because this voltage here is lower than the Zener voltage, there's not enough voltage to go around, that is to be split between here and the Zener, in order to keep the Zener sufficiently reverse biased. So if the input voltage is below VZ, right, then the load voltage here is going to be down. Okay, it's down much lower than we would expect because there's just not enough voltage to go around anymore. Okay, all right. So if we were to set this, just put it to VZ. You're always going to want it more, at least several volts more. We're just going to just see what this is going to do. Okay, even that it's not high enough. Okay, to have the Zener sufficiently reverse biased. And okay, so let's put this back to 9. Okay, and then we're going to hit start. Okay, and everything's back to normal. Okay, so anyway, I hope this was clear. That's all the essential points, and we'll catch you later. Okay, bye-bye.